Okay, in order to use GeoGebra online, first thing we'll do is we will Google GeoGebra, and we will see that one of the options is GeoGebra Classic, and that's the one we'll use. And we'll then get a panel like this. And what we want to do is we want to select from this spreadsheet. And when we do that, we'll see that we get a grid here, and we have columns named by letters, rows named by numbers, and that's similar to what we get when we open a spreadsheet in Google Sheets or in Excel. So it's a very common spreadsheet structure. Okay, so let's create our matrix. So we'll just do 1, 2, 3, 4, 5, 6, 7, 8, 9, and now we have a 3 by 3 grid that we're going to select, and then we're going to click on this option right here. And this will, when we do that, we'll see we have a couple of possibilities. We can create a list of points, a matrix, table, polyline. We're going to choose matrix. And then we'll get this dialog box. It says matrix, name, and let's call this, we'll call this matrix 1. Or we can just use the default assigned name of M1. And we're going to click, well, it's already pre-selected, but we'll click on default objects, dependent objects, because we want our matrix values to be dependent on these values in the spreadsheet. And that's, in order to do that, we have to have dependent objects selected. Okay, and we click create, and GeoGebra has created the matrix, but we don't see anything change. In order to see anything change, we need to look at the algebra view. So we click on view, and then we click on algebra, and we can see now this is a list of objects that have been created by GeoGebra, and we have matrix 1, and it shows what matrix 1 is equal to. Okay, so now let's try some matrix operations. So we can say matrix 1 squared. And we get a new matrix, and this is equal to matrix 1, matrix 1 times matrix 1. And so now we have created a second object called M1, and now we could do some operations on that. We could say, all right, what is 5 times M1? When we do that, we create yet another object, M2, in which each of the cells in M1 has been multiplied by 5 to create this matrix M2. Okay, we could also say, let's take matrix 1 and raise it to a power. Higher than 2. Let's say 5. And because of the numbers we chose, we're going to get some very large numbers here. If we had chosen different numbers, we could have gotten something different. And we could have chosen something so that we would get, if we were dealing with probabilities, for example, where our values were all between 0 and 1, we would get all values in our matrices where we've raised them to high powers. The values would still be between 0 and 1. Okay, we also have a couple of other operations for matrices. We can do invert, and that will create the inverted matrix. So let's do the inverted matrix of 1, and no, it didn't like that. But let's try transpose, and what that does is it swaps all of the rows and columns. And so now, instead of having row 1, 2, 3, 4, 5, 6, 7, 8, 9, we have columns 1, 2, 3, 4, 5, 6, 7, 8, 9. So now we could say, well, let's see what happens when we multiply matrix 1 times M4. And we get this interesting looking thing here. So as you can tell, there are a lot of matrix operations that we could carry out. And this will help us when we want to, say, take a matrix and raise it to the 1,000th power, because we want to see what happens if we have a Markov chain and we allow it to operate through 1,000 cycles.